Good afternoon, everyone. My name is Difan, and it's my honor to be one of the recipients of this year's RM Quigley Award. For the past 2 years, I've been working on a project, Geoelectrical Signatures of Acid-generating Waste Rocks, and I'd like to express my gratitude to my supervisor, Dr. Christopher Power, for his invaluable support. Mining is extremely important for the development of our modern society, but mining can also produce significant amount of waste rocks that are stored at the ground surface as waste rock piles. Once exposed to atmospheric water and oxygen, these waste rock piles can generate a toxic leachate called acid mine drainage and pose threats to our environment. Understanding how waste rock piles generate and release acid mine drainage is highly desirable by the industry to prevent environmental contaminations. The traditional method we use to monitor the generation and release of acid mine drainage is by using monitoring wells and core sampling. However, these methods are invasive, costly, and can only provide us with low-resolution data with limited spatial and temporal information. An attractive alternative is the non-invasive geoelectrical technique, spectral-induced polarization. This technique can create images of the subsurface, similar to how X-ray imaging shows the inside of human bodies. But currently, there's still a lack of research on its application on real mine waste rock samples. Therefore, the objective of my research is to examine the geoelectrical signatures of actual mine waste rocks, as well as to evaluate the true feasibility of the spectral IP method to be used as a waste rock monitoring tool. For my study, waste rock samples were collected from 3 reclaimed waste rock piles situated in Cape Breton Coalfield, Nova Scotia. Each of these samples was placed in flow-through columns and subjected to water and air influx over several months. During this period, geoelectrical signatures of the samples were recorded along with their geochemical behaviors. Through the extent of my research, we discovered that one of the parameters measured by the spectral IP method exhibit strong sensitivity in detecting water quality anomalies in the waste rock core channels. Excitingly, this leads us to believe that the spectral IP method can be used to identify the precise location and the time frame at which acid mine drainage formed within the waste rock piles. This finding offers a new perspective for acid mine drainage monitoring and highlights the advantage of the use of non-invasive geological methods in waste rock pile monitoring. And with that, I'd like to thank you everyone for listening, and I'm grateful for the GRC for honoring me with this award.